So our second concept is changing momentum. So remember, we're still talking about objects that are in motion. So when an object's velocity changes in magnitude or direction, its momentum will also change. So let's assume the object does not break during a collision. So suppose this is a wall, and then someone standing here kicks a ball, and this ball has a mass of 0.5 kg, and then kicks a ball with a velocity of 2 meters per second. Obviously, the ball will bounce on the wall with a velocity, with a different velocity. Suppose the velocity at which the ball now is traveling at its 0.8 meters per second. So now they want you to calculate the change in momentum. Ne? Remember, from grade 10, we learned about change in velocity. And when we talk of change, we just talk of the final position minus the initial. So symbolically, when we're talking about change in velocity from grade 10, it means we're having delta V is equals to V final minus V initial. So now we have what we call change in momentum. So it means we're going to say delta, which is standing for change, and then momentum, we know that this is represented by small letter p. So it means we're going to have a p final minus p initial. So this is the formula for change in momentum. Okay, so when we talk of change in momentum, we say this is p final minus p initial. Okay, remember, momentum, it's mv, mass multiplied by velocity. So it means the mass will be the same because it's the same ball that is kicked and bounced off the wall. So it means the mass is the same, but the velocity, we have the final velocity and the initial velocity. So it means here the pf will be mv minus mv final. So because the mass doesn't change, it means we can make m the subject of the formula and then have vf minus v initial, because the mass is constant, but only the velocities are the one that differs. So if we were to calculate the change in momentum of this scenario, it means now our mass in this case is 0.5 kg. Okay, and then we have our v initial, the velocity at initial, which they kicked the ball, it was 2 meters per second. Okay, and then now we have our v final, which is 0.8 meters per second. So now remember, in the beginning we said that momentum has to take direction of what? Of the velocity. And in this case, we have a ball moving in two different directions. So it means we must first take what? Take direction of the motion. So when we take direction of this motion, we can say we take right to be positive. So it means this velocity will be positive 2. And then this velocity here, because it's going in the opposite direction of right to 2, it means it will be negative. So it means this is positive 2, and then this is negative 2. I hope that makes sense and we're still together. See, so now it means this is our information, and then we have to calculate the change in momentum. So it means now change in p is equals to m v final minus v initial. So it means now we have our mass to be 0.5, and then our v final, it's negative 0.8, and then minus the initial, which is positive 2 meters per second. So we get our calculator, and then we have 0.5 into negative 0.8 minus 2, and then we get our answer to be negative 1,4. So now it means our change in momentum is 1,4 kg meters per second, and then to the left, because this negative here is the one that shows us the direction of the momentum. Okay, so now let's suppose this is the ceiling in the house. This is the ceiling, né? And then someone throws a ball, and then this ball goes to the ceiling and then comes back. So the mass of the ball is 1,2 kg, and then it was traveling at a velocity of 2 meters per second, and then when it's coming back, it was traveling at 1 meter per second. So now we have a different scenario, but it actually is the same scenario. It's just that here the difference is only on direction. So even on this case, you must first choose direction. So in this direction, we have in this situation, we have up and down. So we can choose up to be positive. It means down will be negative. So when we collect our data, then it means mass will be 1,2 kg, and then the v initial, the initial velocity, it means we took up as positive. It means it will be positive 2 meters per second, and then our v final will be 1 meter per second, but it's going down. It means it will be negative 1 meter per second. So if we were to calculate the change in momentum, it means we're going to say change in P is equals to P final minus P initial. Okay, so our change in P will be equals to mv final minus mv initial. So you can write it this way. You can say this is 1,2, and then you multiply it by the final velocity, which is negative 1, and then you subtract, and then our mass is still the same. It's 1,2, and then our v initial was positive 2 meters per second. And then when we simplify this, it means here we're going to have negative 1,2 for this one, and then minus, and then when you multiply, sorry, that was my calculator. When we multiply 1,2 by 2, we get that is 3, it's 2.4. So it means we subtract 2.4. So now it means we have minus 1,2 minus 2.4, and then we get that to be negative 3.6. So this negative shows us what? The direction. So it means now our final answer should be in the case whereby we write 3.6, and then the units kg meter per second. Then this negative here comes here to be the direction. Then it means now our direction is what? It's down. So it means here it's down, or you can write downwards. I hope the part of changing momentum makes a lot of sense. The main objective for this is to choose direction for the velocity, and then everything will go accordingly.